In this video, we're going to be talking about exponential functions. And first off, an exponential function is a function of tremendous growth. It's a function when we deal with bacteria growth, things that duplicate, double and triple and quadruple, those are exponential type functions. The parent function for an exponential function is y equals some number to the x power. Notice the x is in the exponent. And you could take this and you could experiment. You could do 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, and see what happens. It gets bigger and bigger and bigger, and actually very quickly. If b is greater than 1, if this number is greater than 1 as it was here, like it was 2, the function is an exponential growth function. And is always increasing. Because notice 2 to the first, that's 2, 4, 8, 16, then it turns to 32, 64. If your number b is a fraction or a number less than 1, like 1/2, if you do 1/2 to the first power, then 1/2 to the second power, and you see what happens, you do 1/2, 1/4, 1/8, 1/16, 1 over 32. This is called exponential decay, and it would always be decreasing. And again, you could check that 1/2, 1/4, 1/8, 1/16, 1 over 32, 1 over 64 gets smaller and smaller and smaller. A reminder, we've talked about asymptote lines in the past, and that asymptote line is a line that your function gets close to but never crosses. And we'll see that in each of these exponential growths and decays that we will have an asymptote line. So number one, let's classify as an exponential growth or decay, and we can do that just by looking at the number here. If it's a number bigger than 1, it's growth. If it's a number smaller than 1, it's decay. So therefore, this would be an exponential growth. So it's going to get bigger and bigger. We're going to graph it, then we're going to identify its key characteristics. And I've done me a t-table here. Now, just a quick reminder, to plug -2 in for x, that'd be 2 to the -2 power. You will have a fraction bar, bring it to the bottom, and that'd be 1 over 2 to the +2, which is 1 over 4. You do the same thing when you plug in a -1. 2 to the -1, bring it to the bottom, that'd be 1/2. Anything to the 0 power is 1, and then you have 2 to the first, 2 to the second, 2 to the third, and now let's plot these points. And here you get a look at what the graph would look like. Now I do want to point out, as we go to the left, notice that you had 1/2, then you had a fourth, then you'll have an eighth, a 16th, 1 over 32, 1 over 64. This gets closer and closer and closer to the x-axis, but it's not going to touch it. That's going to be your asymptote line. The x-axis, which is y equals 0, will be the asymptote line of the graph. We'll go ahead and plot that. Your domain, you can plug in anything you want to. Negative infinity to positive infinity. You could even plug in fractions. Reminder that if you were to plug in 1/2, that'd be 2 to the 1/2 power, which we just talked about a few lessons ago. That's a rational exponent is a radical. That's the square root of 2. The range, notice that you never go past 0. It actually, there's an asymptote line at 0, and your graph goes up from there. So it'd be 0 to infinity. As you travel to the right, your graph increases. As you travel to the left towards negative infinity, your graph goes to 0. You have a y-intercept right here at 0, 1. Your next graph, y equals 3 to the x, would also be an exponential growth because of the 3. So you have a growth equation here. Let's do us a t-table and do the exact same thing we did on our last one. We'll plug in the same values, -2, -1, 0, 1, 2, and 3, and here's what you're going to get. And a reminder, the way that I got that 1/9, when you plug in and do 3 to the -2 power, fraction bar, bring it to the bottom, that's 1 over 3 to the +2. Let's plot these points and see what the graph will look like. And it looks like your graph looks just like the first one. The difference is, though, it grows faster. 3 to the first, 3 to the second, 3 to the third grows faster than 2 to the first, 2 to the second, 2 to the third. So that number kind of tells you how quickly it's growing. The domain, you can plug in anything that you would like into these. There's no domain restrictions. The range, however, you do have that same asymptote line at 0, so your range values will go from 0 up. In behavior, as you travel to the right, your graph goes up. As you travel to the left, your graph again levels out. to this asymptote line, which is at 0. Your y-intercept is again 0, 1, because if you plug in 0, anything to the 0 power is 1. And that asymptote line again is the x-axis, which is located at y equals 0. 1/2 to the x, now you have an example of exponential decay. So let's make us a t-table and let's plot these points and see what's going to happen. We'll plug in the exact same values. Well, we might flip-flop these and do -3, -2, -1, 0, 1, and 2. And you'll see why as we plug these in. Reminder, to do 1/2 to the -3 power, which is the first one we're plugging in. To raise a fraction to a negative exponent, you can flip your fraction and change it to a positive. So 1/2 to the -3 is 2 to the +3, which is going to be 8. Do the same thing with the -2, and you're going to get 2 to the second, which is 4. 2 to the -1 is 2. Anything to the 0 is 1. 1/2 to the first power and 1/2 to the second power are these values, which will look a lot like our first function values. But let's plot these and see what happens. And you see here that it's actually the exact same graph as your original, except it's flipped over. And there's a reason for that. If you actually took 2 to the x, changed it to 2 to the -x, that would be a reflection across the y-axis. Well, think about what you can do with 2 to the -x. You could take that 2/1, you could flip it to 1/2 and make it a positive x, because to raise a fraction to a negative, you can flip the fraction, which is the exact same we just graphed. So that's simply a reflection across the y-axis. This would be an example of exponential decay. You have the exact same asymptote line there at y equals 0, your x-axis. Your domain, again, you can plug in any values that you would like. And as you plug those values in, your range values are still from 0 to infinity. Notice I don't include 0 because that's my asymptote line. It doesn't touch it. As we go to the right, my graph levels out to that 0. As we go to the left, my graph grows upward. My y-intercept, again, when I plug in 0, I get 1, so my y-intercept is going to be 0, 1. The next one, 2/3, is also a fraction less than 1, so we'll see another exponential decay here. Let's do us a t-table. Plug in some x and y values. We'll plug in the same ones, -3, -2, -1, 0, 1, and 2, and let's see what we get. And here's your graph, and again, notice what I did here. When I plugged in -3, I flipped my fraction. That made it a +3. And I raised the top and bottom to the third and gave me a 27/8. And I just changed that to a decimal and I plotted those decimals. My range, again, with this exponential decay is still, you can raise anything or a number to any power you want to. So therefore your x value can be anything. Your range, however, will never be 0, and it goes up from there. As you move to the right on your graph, since it's decay, your graph levels out to nothing, 0. As you go to the left, your graph grows without bound. Your y-intercept, if you were to plug 0 into your function, it would again give you 1. Your asymptote line is also, just like the other ones, the x-axis. Graph one more, y equals 5/2 to the x. Now be careful, because a lot of people see fraction and they say, oh, this is going to be decay, but that fraction is 2.5. That's bigger than 1, so this should be an exponential growth. So from left to right, this should be an increasing function. Let's do a t-table. Let's plug in the same values and see what we get. And there is our graph. And again, notice that from left to right, this is a growth function. Domain, all real numbers again. You can plug in anything. Your range, same thing, 0 to infinity. As you move to the right on your graph goes up. As you move to the left, your y value levels out to 0. Your y-intercept again is 0, 1. When you plug in 0 to give you 1. Your asymptote line will be the x-axis, which is y equals 0.